When we talk about ecosystem vulnerability, we talk about it as consisting of a number of different things. You know, you can look at ecosystem condition and whether it's a pristine ecosystem is good or it's stressed or it's degraded. That's very important for its sustainability and its resilience. It's also it's important to take into account the value of that ecosystem to society, and that clearly makes a difference as to how well it's protected or if it's exploited, et cetera. In terms of risk management decisions, we have to look at the feasibility of, we have limited resources, so we have to look at the feasibility of addressing different problems. We have to figure out what kinds of actions work in which different places, and we need to look at a whole range of methods that can be applied. The Regional Vulnerability Assessment Program, which is where most of this was derived from, was initially given the task of looking at multiple stressors affecting multiple resources, and that's human resources as well, and all at the same time, simultaneously, rather than looking at things one at a time, like just water quality or just air quality, with the idea that, again, we have very limited resources to address these, so we really need to be able to step back and prioritize where we're going. We also recognize that we need to be able to incorporate various perspectives from different stakeholder groups, those that are trying to promote economic development versus those that are trying to promote conservation biology. And we have to figure out how to balance among those and evaluate the trade-offs in a way that makes sense to everybody. Our clients for the REVA program were the people who enforce our regulations, the people who set our regulations, and then the state and local decision makers who actually manage the compliance with the regulations. We basically look at it as anybody who has need of this kind of information and doesn't have it in their hands now. When we look at ecological vulnerability, we typically consider 5 different areas that are drivers of ecological change. These, and we look at these in terms of how our environmental compliance with regulations, how successful that has been. We've had great compliance with our Clean Water Act, with our Clean Air Act, with our Endangered Species Act, in terms of people obeying the law. But we do recognize that we are still seeing declines in biological populations. And the reason is we have problems that are bigger than we've ever had before. They're larger in scale, they're much more difficult to address, they have lots of different components, and we don't understand a lot of them. So these include land use change, resource extraction, so this would be mining or timber operations, pollution and pollutants. Pollution would be air pollution, for example. Pollutants would be runoff from nitrogen fertilization into water that people drink. Exotic invasive species that typically displace native species. And then, of course, the big one, climate change. So we've done a lot of work with projecting land use change. You can use a suite of methods to do this. You can look at economics, job growth, et cetera. You can look at planned roads and planned developments and actually map those and say, okay, we know these are going to occur, they're planned. This is where we need to look at what's going to happen. And it's also important to consider that the processes are very different between rural land use change and urban land use change. So you need to use a different suite of methods. This, of course, can provide input into decisions that affect conservation of native biodiversity, increased risk of flooding, non-point source pollution, urban sprawl and quality of life, drinking water quality supply, pests and pathogens in forests with the exotic species that come in and make the trees all die, and then, of course, economic opportunities, which is also a very important part of this. An example of some of the work that we've done is from the Mid-Atlantic region. This is a multi-state region, and I apologize, I don't have a map on the United States showing where this is, but this is where the yellow part on the right-hand side of this map is around where Washington, D.C. is. Over on the left, in the state of West Virginia, which is a very remote state, not very many roads, lots of very steep hills, we do know that that is a globally unique area in terms of intact, non-fragmented forests, which is very important for biodiversity globally. At the same time, it has the highest unemployment in the region, and it's been targeted by mountaintop removal mining, which is a very devastating approach where they basically go in and cut the top of the mountains off and then take all that refuse and dump it into the nearby stream. So it's causing a lot of problems in this part of the region. We also have expansion of chip mills, forest chip mills, that go in and take whole trees and then move from one place to another without replanting. So of course we have potential impacts on the native biodiversity, water quality, and of course quality of life for the people that live there. So what we've done for the Mid-Atlantic region is we've actually looked at all of those 5 drivers of change, and these are just some examples of what we've done. And we projected them out 20 years in the future to try and look at where we're going to have problems in the future. So on the left, you see the land use change modeling, starting with the current time, which at that time was the early 2000s. We projected to 2020. So you can see the change in the urbanization with the red on the map. We looked at our air pollution projections with the new laws that EPA has put into place and how that would change air pollutants over the region. We also looked at a suite of invasive species. We went to resource managers and asked which were the ones that were the most problematic, and we modeled where those species would likely occur under current scenarios and under climate change scenarios so that we could put all of this together. And then we did. We put it all together, a lot of different coverages describing the current resources and then the future stressors. And we're able to look at, on the left, you have the current conditions where things are okay, and then we had the future conditions, and then we did a difference map so that we could identify those specific places where changes are the most important. And that gave information to the EPA regional office there as to where they might target discretionary funds for both outreach or for mitigation or for something else that would improve environmental conditions. Another study we did was much smaller in scale. It was for Charlotte, North Carolina, which is just a little bit smaller than Mérida. In North Carolina, it does have a location map there, where we were looking at 2 alternatives of future development. Charlotte was known in the Southeast as being one of the most sprawling cities in the country, with increasing problems with air pollution and water pollution. Because of that, people would live way far away and drive into work every day. And so we did a regional assessment of that. We worked with the local developers and government officials there to say, okay, what kind of a future would you like to see? So on the left, you see the projection of what growth as usual, if we just continue the sprawl, would look like, and what that would mean in terms of the total land consumed, changed from the natural environment to impervious surface, et cetera. As an alternative, we looked at centers of development that would promote mass transit and would conserve much more of the land. And then we looked at all of the changes associated with water quality, air quality. We actually looked at tax revenues because that was important. You know, developers are always saying, if you do this development, you'll bring in more tax revenues and it'll all be great. But you have to look at the cost of the infrastructure associated with that as well. So just another view of how we did this for the medium density development, which is the continue as we're going. We had fewer houses per acre, more land consumption, decentralized employment, so people do have to drive all over the place, no mass transit, as opposed to centers of development, which have more houses per acre, but we believe can provide a greater quality of life within that, less land consumption, centralized employment. People don't have to drive 50 miles to where they work, and then providing the opportunity to have mass transit, which will help our air pollution problems a lot. We put this into another web tool, made it available to the people of the region. They used it for visualization, and they're actually moving in the direction of the compact centers now. This is just another version of one of the measures we use, which is a human use index. It basically takes areas that have been modified by people, so agriculture, impervious surface, et cetera, and puts it in a ratio over natural lands. And so this is looking at how that's changing over time. The difference map on the bottom is showing you that those areas that are in the gold and brown are better with the compact centers. So the other thing it illustrates is there are trade-offs. There are sometimes when you do the compact centers where you get more, well, you would actually lose water quality or something like that. Sometimes if you have impervious surface and not agriculture going on, your water quality is better. So there are trade-offs. There's always trade-offs. You have to look at that. You have to consider that. This is just the net changes of everything we looked at. And again, we did find that overall, the compact centers would provide a better quality of life. So again, this is something that's going into the decision-making for the city of Charlotte, North Carolina. Another much bigger study that we've done is the Future Midwest Landscape Study. This is an 8-state study looking at a policy that the U.S. government has put in place, the Energy Independence and Security Act, which mandates the production and use of biofuels as a way to try and become more sustainable. The way they've done this, they've set actual amounts of biofuels that need to be produced, starting with corn-based ethanol, and then in the future moving to the more benign cellulosic types of ethanol. So what we wanted to do is say, okay, this might be a good idea, but we really want to look at how this affects the environment within the region. So what we did was we looked at if we're going to accomplish what we have been mandated to do in terms of corn production, it's going to require that we change the way we manage our crops. In the past, most of the Midwest did corn, soybean, corn rotations, which allowed the ecosystems to recover somewhat and would fix nitrogen into the ecosystem. So we'd have to shift to a corn, corn, corn rotation. So no soybeans, just corn. Corn, unfortunately, requires a lot of chemical inputs. So what we saw with the increase in corn production, which is the green area on the map on the left, we see a huge increase in nitrogen fertilization. This has implications for air quality and for water quality. And we see a huge increase in atrazine, which is an herbicide, atrazine application. Atrazine has been linked to deformities in amphibians and also to hormonally based cancers. So we see this could be a big problem. Another thing we've done with our geospatial tools is the ability to say, okay, now that we have this information, how do we put it together in a way that will actually help us target where people are going to be vulnerable? So this is an example. We took the atrazine application, which we can get from USDA, the typical application to raise a certain kind of crop. We can look at individual surface water use, how many people are using surface waters, where the atrazine is being applied, and then the population density. So you can put that together and come up with what is a much better index of exposure to atrazine for people, and it shows you where these exposures are likely to occur. So these are the places we want to go out and do outreach and talk to the people and also see if there are ways that we can mitigate the use of atrazine across the region. Is that another thing that we've done within the program is look at how you put these data together. And the main thing I want to get across with this one slide is that you can put the data together in different ways and you'll come up with completely different answers. We've done a lot of work looking at this and have some guidance on that. We're actually going to be developing tools that will be available on the web that will help you ask the right question using the right integration method. For the future, we are developing an Enviro Atlas for the 48 conterminous U.S. states. We think it's very good. It's going to be available publicly within the next year. It's scalable. It has two scales. One, the national wall-to-wall coverage of all kinds of information on ecosystem services. This is air quality, water quality, biodiversity, access to green space, things like that. The built environment, so where we have landfills, where we have lots of roads, things like that. Demographics, because it's very important for us to be able to look at EJ issues, environmental justice issues, and where benefits or impacts are disproportionate across the map. And we're also going to be looking at drivers of change. So we'll be doing some what-if scenarios, looking at changes, projected changes in pollution, projected changes in population growth, and projected changes in land use development. And then we have analytical tools that will let you do a lot of things with these different coverages. Another component of this is the high-resolution analysis that we're doing for communities. This we're doing at a 1 meter scale. It's starting off pretty slow because we're developing the methods right now, but we actually hope to have 250 urban communities where we can do a much better job of linking ecosystem services to human health and well-being. And again, do these queries on subpopulations of concern and hopefully actually identify some actions to mitigate pollution and reduce energy, for example. And this is just an example of some of our very high resolution work where you can look at tree cover and how that removes ozone, which is a oxidant. It affects people's lungs, respiratory systems. And then the value of that in terms of how you might reduce hospital visits, et cetera. We can also look at temperature and heat island effects and vulnerable populations such as the very old and the very young and where those might be occurring. And then another thing is we can look at the potential for tree cover to actually buffer air pollutants along roads. So we can identify areas that we could plant additional trees, particularly if they are near schools or playgrounds, and hopefully reduce the exposure to air pollutants for our children. There is the effort by the CEC to do the North American Atlas. This is an area we really do hope to collaborate with CEC on, sharing some of the things that we've developed with our Enviro Atlas and expanding it to all of North America with, again, the idea that this will provide a resource for communities and decision makers across North America.